Guys, welcome to the new lecture of this particular course. So now in this, till the last lecture we studied some of the very important concepts, like we implemented the concept of range, standard deviation, variance, and percentile and quartile. We have implemented all of these things. Now we have to understand the statistics in terms of graphical representation, as data visualization is also very important when we try to do the statistical analysis. So for doing this statistical analysis, one very important term comes is data visualization. So in data visualization, basically for now we're going to focus on three important plots: histograms, box plots, and scatter plot. And today we will going to study the three concepts. What is the histogram? We will study the types of the histogram based upon the skewness, and then we will going to study about the histograms based upon the modes. So let's go and let's study the concept of histogram. So now we will going to study about the histogram. So what is the histogram all about? It's a graphical representation of data. Graphical representation of data. So what is this graphical representation of data means? Through the help of graph, you can able to understand the insights from the data. You can able to do the analysis from the data. So for this, some of the plots like histogram plays a very important role. So what is this histogram does all about? Histogram represents the continuous distribution of data. Here the distribution of data is continuous. The distribution of data is continuous. Meaning what? Here the continuous. Means what? In histogram the distribution of data is always continuous. Means what? It always, let's say, from 0 to 10, one particular value, some people are there. From 10 to 20, some people are there. Means the data is always in the continuous form, not like separate bars you are making, like that it is not there. So I will take one example to explain you what is the meaning of distribution of data continuous. Now I will take one example. Let's say you are having the students who scored some marks. So let's say marks of students. And in the marks of students, what we will write this, let's say this is your X column, and here you will write a score, like number of students. So from the range of 50 to 60, let's say 5 students have got from 50 to 60. From 60 to 70, let's say 10 students are got. 70 to 80, let's say 10 students are got, and 80 to 90, let's say 5 students are got. Okay, so these are the marks. We are taking this particular table, and let's say 90 to 100 have also got 5 marks. So now what happens? Now we will plot the graph. Okay, we'll plot the graph. Let's say this is your x-axis, this is your y-axis. What is x-axis? Marks. What is y-axis? Number of students. So how you got the number of students? You got the number of students value based upon the frequency. You have data. Then in the last lecture we studied about the frequency, and in the frequency we have studied that how many people you got. That count you will going to write, that we studied. So that is what is this value you got. So now here what I will write here, I will write from 50, 60, 70, 80, 90 and 100 and 100. I will write x-axis. Now what I will do, here I will write values. How many? 5 and 10. Okay. So now here what I will do, from 50 to 60, how many people have got 5 marks? 5 people have got 5 marks. So we will write here, we will draw like this. From 60 to 70, 10. So 60 to 70, 10. 70 to 80 also 10. 80 to 90 it is 5. 90 to 100 it is 5. So now if you observe here, total now here you see, here if you see this particular plot which is formed is called as histogram. Why it is called as histogram? Because here the data is continuous and you are seeing through pictorially. So this plot is called as histogram. Here hist means histogram. So now here you see that here you see these boxes, right? Total how many boxes are there? 1, 2, 3, 4, 5. So in histogram these boxes are called as bins. So total how many bins are there? 5 bins are there. Now you can divide these bins into different equal halves also. You can play with the bin value also. Now let's say if I keep my bin value as 10, let's say if I keep my bin value as 10, now what will happen? This particular histogram, it will divide it into bins. Like let's say this is one bin, this it will divide it into half bin, half bin. This. Here it will become 55. Now it will tell the people who have scored the marks between 50 to 55. Similarly 55 to 60, 60 to 65, like it will going to show the marks, and based upon that your plot will change. So if you play with the bin value, now if you count this particular bin, here you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So like this your histogram will always be divided into bins here. So that's why when we write program in Python, we should always specify the bin value, as based upon the bin value your plot will look like. So now I will take one example, because sometimes the benefit of using histogram is it can able to help us in identifying the outliers. Helps us in identifying the outliers. So what are the outliers if you ask me? The extreme values which are not in this range. Like some people, like let's say if out of 100 people, if one person is the class monitor. So that one class monitor is what? He is extreme because he is not similar to other people. He is having some other responsibilities and other powers which human does not have. So that one person is nothing but an outlier. So like this in data also you might have some extreme values. So to deal with that extreme values, to identify it from data itself, we will be using this histogram. So it helps in identifying the outliers. To identify the outliers, your histogram is divided as per the skewness. Histogram is divided based on skewness. Skewness means what? Depending upon the plot you have, you can identify whether the particular data has some outlier or not. So based upon this, we will going to study the types of the histogram. Just now we studied the concept of histogram. So now we will go through the notes. So when I say about histogram, it is the graphical representation of data distribution using the bars to show how frequently value occurs within the certain ranges. So just now we saw, right, what is the value of bin, how the bins are been calculated. Just now we saw, right. So X represents the data intervals where the Y represents the frequency, means the count of that particular range it will shows. Because the data is continuous. Here always the data is the continuous. Now then we studied about the purpose of the histogram. So what is the purpose? You should understand the data distribution patterns, that you have to understand, that is important. To identify the skewness and spread, that is very important, and to detect the outlier, it is important. So example like plotting ages of 100 people shows how many people fall within this particular ranges is one of the example. So now based upon the particular thing, histogram is divided based upon the types of skewness. Now we will going to study the concept of types of skewness. Now we will going to study the types of histogram based upon the skewness. Now I will take 3 examples to show what are the types of histograms that we have. We have 3 types of histogram. One is the symmetric skewness. One is the symmetric skewness. One is the positive skewness. Positive skewness. And we have the negative skewness. Negative skewness. So these are the three types of skewness that we will going to see. This positive skewness is also called as the right skewness. Right skewness. This is called as left skewness. Now I will take one example to show these three types. I will take three examples here, one, and I will going to plot it. I will tell you the difference between this. Now let's say in symmetric, I will take one example as, let's say you are having the same, like student marks we are having. So marks scored by the students, marks and number of students. Okay, this is X, this is Y. Let's say you got 60 to 70 as how many? Let's say 5 you got. 70 to 80, let's say you got 10. 80 to 90 you got 10. 90 to 100 you got as 5. Okay, now in this example, now if we try to plot the histogram, how the histogram will look like? Here it will be X, it will be Y. Now here we will write 5, we will write 10. Here we will write 60, 70, 80, 90 and 100. Now what we will do, we will plot it. From 60 to 70, how many of them got? 5 of them got. 70 to 80, 10 of them got. 80 to 90, 10 of them got. 90 to 100, we got 5 of them. Correct. Now here if you see, now here we will going to learn a new concept called as density curve. What is the meaning of density curve? Density curve means from the top point of this particular thing, this particular center point of this particular lines, bins, center part of this bins. Here you will try to draw the line. So here you will get the line like this. Okay. Now here you observe, you got this line here in this format, you got the line. What is the meaning of this particular thing? Means your data is in the proper distributed form. Means this data does not have any outlier. Here the data is properly distributed. Data is properly distributed. Properly distributed. So in this case, what happens here? Here let's say if this particular value is the center value. Obviously we know that mean, median, mode, we always deal with the center values, we will going to deal. So here in this case, your mean value, your median value almost will be same, and mode value, these three values will be almost same. If let's say 51.5 is the mean, 51 is the median, 52 is the median. So nearby this only these three values will be there. So now here this particular plot which we got just now is called as the normal distribution plot. So this is called as normal plot, normal distribution plot, normal distribution density plot. So here you see, here this particular plot has formed. So for this particular plot, your mean, median, mode will be this center value only. So because here you don't have any outliers present. But in positive skewness and negative skewness, you will be having the outlier. So in symmetric, here one point I can write as the, here the no outliers are present. No outlier present. But to explain the positive skewness, I will take one very good example for this. Yeah, let's say here X is your this, Y is your this. Let's say here we will write it as the marks only, we will say. We will take example of marks only. Here we write number of students. Number of students. Now let's say from 40 to 50. 5 students have got 40 to 50. 50 to 60 you got 10 students have got. Directly after this what will happen? 60 to 70 no one has got the marks, 0 of students got this marks. Some 70 to 80 how many of them got? Let's say again you got 0 marks, and from 80 to 100 you got 5 marks. Sorry, you got let's say 1 mark you got. Okay, 1 mark you got. Now what will we do? We will draw this plot again. So if we try to draw this plot now, here what will happen? You have to start with the 40. 40, 50, 60, 70, 80 and 100. See here you see only one student has got the highest mark. Rest all students are in the range of 40 to 60. Means this one person who is there in the class is an extraordinary person. He is the topper of the class. So his way of studying will always be different than others. So this particular one is nothing but an outlier. I hope you understood this example. Like topper of the class, only 1% will get the out of marks or 1% will get the maximum number of marks. That person is an outlier because he got an extreme value. Now if you try to draw the plot here, from here let's say we'll write 1, 5, 10. Now if we try to draw the plot, from 40 to 55 people have got, from 50 to 60 10 people are got, from 60 to 70 0, 70 to 80 0, from 80 to 100 only 1% got. Now here you see this particular plot here. This is not a normal distribution plot. If you see this particular plot, you will observe that here the graph, here it started here like this, but from here it is going towards the right hand side. It is going towards the right hand side. Okay, here the graph is towards the right hand side. Here you see this graph is going towards the right hand side. Since it is moving towards the right hand side, it is called as the right skew. So here you see this particular value. From this you can see that this is an extreme value. Whenever the value is extreme, we say it as an outlier. This is the major concept behind it. So here the plot will look like this. It will go like this. It will go like this. This is not the normal plot. So now here in this case, what will happen? Always your median value will be greater than the mean value. Always your mean value will be greater than the median value. Always remember, median value will be greater than the mean value because the outlier is present in the right hand side. So this is how your positive skewness works. Here the data is not properly distributed. This is not the normal distribution because data is not distributed normally. That's why this is the positive skewness. The third type of skewness that we have is negative skewness. Here same xy we will take x as marks, we will take as number of students. Now here what happens? Like here, like in your class, let's say if one person has got the maximum number of mark, means he is the topper. If one person who got the least number of mark is called as the failure. So the person who got the least number of mark, that also can be possible. Then so that example only we are going to take. So let's say from 0 to 10, let's say one student have got the mark, and directly from 80 to 90, 5 people have got, 90 to 100, let's say 10 people have got, and 70 to 80, let's say 5 people have got. Now if you try to draw the plot between this thing, here we will take this plot, here we will write 10 here, then directly we will going to write 70, 80, 90, 100. Now here you see in this particular right skewness, from 50 it is directly going towards the 100. Means the data is not normally distributed. It is distributed, it is moving towards the right hand side. So here now what we will do, we will try to draw the plot behind it. So now 0 to 10, let's say here 1 are there, 5 is there, again 10 is there, okay. So 1 to 10, one person has got this particular mark from 0 to 10. Now from directly 10, you have skipped till 60, you have skipped till 70 number mark. So from 70 what you are doing, from 70 to 80 you are getting 5 marks. From 80 to 90 you are getting 80 to 90 5 marks, 80 to 90 also you are getting 5 marks, and from 90 to 100 you are getting 10 marks. Now if you see this particular graph, here this graph is coming like this. This graph is coming like this. It is going in very decreasing order. From in the left hand side the graph is decreasing. That's why it is called as left skew. Graph is decreased in the left skew. Here one person has got the lowest number of marks, means he is an outlier, because rest all people have got above 70. One person only got 10, below 10, means he is an outlier. So that's why this value is an extreme value. Extreme value. Now if you see this curve, it became like it starts like this, but it is going towards the left hand side. So in this case, your mean value will be greater than median value. And one very important thing, in positive skewness, what you get the result, the opposite you will get in the negative skew result. In right hand, here you got the right hand side, here you got the left hand side. Here mean value is greater than median, their mean value is greater than the median. Here the median value is greater than mean, there the mean value is greater than median. So like this, if you understood one thing, just do opposite, you will get the value as the negative skewness. So just now we studied the types of skewness. So now we will go through the notes. So what are the types of skewnesses that we have? We have three types. One is the symmetrical, which is also called as the normal skewness. Then we have positively skewed data and we have the negatively skewed data. So what is the symmetrical data? Here the both side mirror each normal to be center. Means what? Here the data is always in the form of the normal distribution. Means the data is always like this, and the center part will represent the both mean, median and mode. Mean, median and mode, all three will represent this. So you here the mean, median and both values will be the same, that is the center value. So this value that you got just now is nothing but the mean, median and mode. Best example is human height distribution. You can take any example. Then second type we studied about the positively skewed, means here the tail extended towards the right, means here the data will be go towards the right hand side, it will be skewed towards the right hand side. Here the mean will be greater than the median and mode. But negatively skewed means what? The tail extends towards the left hand side. In this the median value will be more than the mean value. So here this age at retirement, this you can take these examples. So now we will going to study about the histogram types based on the modes. So now we will study about the type of histogram based upon the modes. Based upon the type of histogram based on the modes, it is divided into three types: unimodal, bimodal, multimodal. Now when we are discussing about the modes, we studied about the unimodal, bimodal, multimodal. Here in unimodal, name suggests if mode is equal to 1, it is called as the unimodal. In bimodal, if mode is equal to 2, you call it as bimodal. In multimodal, if mode is greater than 2, you call it as the multimodal. But now if you want to study this based upon the histogram, then it is said to be peaks. Means here we will identify the peak value. In histogram, this is only the concept, but just we will identify based upon the peak value. Here we will identify based upon the peak value. Identify based on peak value. Peak. P-E-A-K, very important word. Now I will take one example to show unimodal. So the example I will take is very simple. Let's say we are having the data. Here let's say here we are having this particular, okay. Here let's say you got the marks. And here is number of students. Now from let's say 0 to 10, let's say 5 students have got. 10 to 20, let's say 5 students have got. 15 students have got, and 20 to 30, let's say 5 students have got. Now what we will do? Now we will have to draw the histogram. So what will we do? We will draw the histogram. Here in marks will keep as the x and students will keep as the y. Now what will we do? We will write 0, 10, 20, 30 we will write. Now there is no need to write 0 because 0 is nothing but this particular point. So we will just write 10, 20, 30. Here we will write 5 and 15. Now if you see here, now 10 to 20 means 0 to 10 means how many? 5 you got. 10 to 20 means 15 you got. 20 to 30 how many? 5. So now if you see here you see that only one particular mode is coming to you. Only one particular peak is there. So here how many value is there at peak? Only one value at peak. One value at peak. So when one value is at peak, it is said to be unimodal. Similarly, bimodal means if two peak come, you will call it as bimodal. If more than two means multimodal you will call. I will take one example to show this both the things. Now here let's say we are having the example of bimodal. Let's say here we are having the X marks and Y stands for number of students. Number of students. Now here what I will do in marks 0 to 10, let's say 5 are there, 10 to 20, 15 are there. But then you are having, let's say 80 to 90 people, you have 90, 15 are there, and 90 to 100, let's say 5 are there. Now what will we do? You again draw the plot, same plot you are going to draw. Now let's say here I will draw the plot of, let's say, marks comma students, x comma y. Here I will write, here I will write 10, then here I will going to skip and directly I will keep 80 and I will keep on 90 and 100. And here I write x-axis. Now if you see this thing, from 0 to 100, how many of them got marks? Here I will write 5 and here I will write 15. So 0 to 10 means what? 5 you got. Then directly, then 10, here we have to write 20 also, so I write 20. Here you got one particular, the 10 to 20, 15 people have got. And then 80 to 90, then directly what happened? 80 to 90, it has happened 15. And 90 to 100 again 5. So now if you observe here, there are two peak values. This is one peak value, this is two peak value. Since two peak values, so it is said to be bimodal. So what is multimodal? As the name suggests, more than two peaks means you will get the multimodal. So if I draw the graph for multimodal, it will look like this. One. Here I will write this. Then again I will going to write this here. And again I will going to write this particular graph here. So now if you see total, how many peaks are there? One peak is there, two peak is there, three peak is there. So more than two peaks means what? Multimodal. So if you do this thing, this is called as multimodal. So see, just now we studied about the types of modes. We'll go through the nodes also. When I say about types of mode, it is divided into three modes: unimodal, bimodal, multimodal, and uniform model. Now, when I say about unimodal means what? Only one clear peak is been shown in the distribution, as we saw in that example where only one peak is there. In bimodal means what? We have two peaks. Multimodal means what? More than two peaks we have. And in uniform, what happens is that, like, let's say if two of the bins are having the same thing, so at that time you won't get the clear peak. Then if you get such kind of data, it is said to be uniform mode. So these are the four type of modes that we studied just now. So I hope you understood the concept of the histogram. And now in the next lecture we will going to implement the concept of histogram via Python. So that's it guys. Please do like, share and subscribe guys. So thank you guys.